Hello everyone. Today we'll be looking at some quick solutions of All India AIATS Test Series JEE Main 2019 Test 3 Code A and B. So let us look at the first question. Question number 31. Compound A has the molecular formula of C5H8 and is optically active. A on catalytic hydrogenation yields B. The compound B has molecular formula C5H10, is optically inactive and cannot be resolved into separate enantiomers. Compound C has the molecular formula C6H10 and is optically active. Compound C contains no triple bonds. So it is given to us further that catalytic hydrogenation of C yields D, and compound D has the molecular formula C6H14, which is optically inactive and cannot be resolved into separate enantiomers. So the examiner seems to be interested in the structures of A, B, C, and D. So let us first try and figure out the data which is given to us. So compound A has the formula C5H8, which is optically active. So A had a formula of C5H8. It was optically active. On catalytic hydrogenation, it converts into B. B has a formula of C5H10 and it is optically inactive. If you look at C, C has a formula of C6H10. It is also optically active. And on catalytic hydrogenation, C gives us D. The formula of D given to us is C6H14. And it is also optically inactive. Okay. So we can first try and figure out the degree of unsaturations of the compounds which are given to us. So C5H8, the du of A is equal to 2. If you look at B, the du of B will be equal to 1. If you look at C, its du will be equal to 2 again. And if you look at D, the compound D has a degree of unsaturation equal to 0. So if we look very carefully at the first reaction, we can see that upon catalytic hydrogenation, the degree of unsaturations are not completely satisfied. Okay, so it must mean that the compound A is a cyclic structure. Okay. Now, if we look at the second reaction in which C is converting into D, we can see that the compound D has 0 degree of unsaturation upon catalytic hydrogenation. It must mean that the compound C is not cyclic. Okay. So, degree of unsaturation equal to 2 can imply that there can be an alkyne or the compound can be a diene as well. So, the examiner explicitly mentions to us that the compound C has no triple bonds. So the only option left to us is that the compound is a diene. So we can have cumulative diene, we can have isolated diene, we could have conjugated diene, but we have to keep the optical activity into account as well. Okay. So let's first try and figure out the structure of C itself. So C is a diene and the examiner seems to be interested if the compound C may be an allene. So let's first check this option. So allene has a cumulative double bond. Okay. And for the allene to be optically active, the groups present should be different on these positions as well as these positions. So this should not be the same as this, and the group present here should not be the same as the group present over here. So let's try and arrange different species which are left behind from the formula. So we can have an H here, we can have a methyl here, we can have an ethyl here, C2H5, and we can have another H here. So students, we can see that this structure is optically active as it has no plane of symmetry and no center of symmetry. So statement 2 is correct. This compound may be the compound C mentioned in the question. Okay. Let us now look at the structure of A. So we had already seen that the structure A is cyclic as the degree of unsaturation is not completely satisfied when hydrogenation takes place. So in order for the compound A to be optically active, we cannot have a 5-membered ring. We can have a 4-membered ring. So 4-membered ring, there will be a du of 2. It means we must have one double bond. Okay. And for this to be optically active, we could have branching on the carbon where the double bond is not present. Okay. So if you look at this structure has one chiral carbon, and species having one chiral carbon are always optically active. Okay. So this can be the structure A, and this can be the structure C. Let us look at the options now. A and C are both cyclic compound. This statement is incorrect. A is cyclic, whereas C is not cyclic. Compound C may be an alene. This statement is correct. We've already seen this before. Compound A may be an alene. Compound A cannot be an alene, as upon catalytic hydrogenation, alene will lose all of its degree of unsaturation. Okay. If you look at the fourth option now, compound D has less boiling point than neohexane. So if we look at the structure of D produced, so it is going to give us normal hexane. Now students, we know that neohexane is more branched than normal hexane, and due to increase in branching, there is a decrease in the boiling point of the structure. So statement 4 is also incorrect. So we have to mark option 2 as the correct answer to our question. Let us look at the next question. Question number 32. When given alkyl bromides were subjected to hydrolysis in a mixture of ethanol and water. So we have a 80% ethanol and 20% water mixture. At 55 degrees C, the rate of reaction follows the order this. So we have tertiary, which is greater than 0 degree, which is greater than primary, and which is greater than secondary. So the reason for this order is, so students, we can see that since the tertiary is the most reactive, and amongst SN1 and SN2, tertiary halides are not very much responsive to SN2 mechanism. So it must mean that this is undergoing SN1 mechanism, because the carbocation formed is very stable, hence the rate of reaction comes out to be greater than all the other species present. And if you look at the other species, we can say that since the order is such that the methyl bromide is more reactive, it must mean that these species are undergoing SN2 mechanism. SN2 mechanism is generally hindrance dependent. So as the hindrance increases, the rate of reaction decreases. So we can see that the tertiary butyl bromide reacts with SN1 reaction and the other react with SN2 reaction. So students, we can see that the correct answer for this question is option 1. Okay, let us look at the next question. Question number 33. Consider the given compounds. So we have been given 4 structures in which the degree of the alkyl halide is different, and we have to comment on the incorrect option regarding their reactivity in SN2 reactions in general. So students, we're talking about SN2 reaction over here. So we know that for SN2 reaction, 1 degree is greater than 2 degree is greater than 3 degree. This is governed by the hindrance generally. Okay. So among these given structures, we have the 4th structure, which is primary. So 4th will be ahead of the others. If we look at options 1 and 2, so option 1 and 2 are both secondary. And if we look at the 3rd option, we can see that the 3rd option is a tertiary alkyl halide. So we can generally comment that 4 is more reactive than 1 and 2, and 1 and 2 are more reactive than 3. Now if we have to select between 1 and 2, so let us look at the structures now. So structure 2 has 1 phenyl and 1 methyl. Okay, and if you look at structure 1 has both phenyl. And students, we know that the steric hindrance caused due to 1 phenyl is greater than that caused by a methyl group. So the reactivity will be such that 2 is more reactive than 1. So if you look at the correct order for ease of SN2 reaction, 4 is more reactive than 2, 2 is more reactive than 1, and 1 is more reactive than 3. So if you look at the options given to us, we have to mark the incorrect statement. So 1 is not more reactive than 2. So this is the incorrect statement, and we have to mark this as the answer to our questions. The other options are all correct. So let us look at the next question now. Question number 34. On reaction with NaNO2 and HCl, which of the following amino alcohols will yield compound A? So we have a 5-membered ring, and we have to comment on which of these 6-membered rings are going to contract into the 5-membered ring one. So students, if we look at the option P now, so we have a cyclohexene, and here we have NH2 at the axial position, and we have OH at the equatorial position. So we have an H at the axial at this carbon, and we have H at the equatorial at this carbon. Okay. So there is a tertiary butyl group present as well at the equatorial position, and we have an H present at the axial position. Okay. So we have to react this compound with NaNO2 and HCl. So students, we know that NaNO2 HCl is going to attack on the amine, and it is going to convert it into N2 plus, and it is going to make it a good leaving group. Now students, for ring contraction to occur, so this alkyl group must migrate to this carbon, but the migration takes place by only anti-periplanar groups, which means that the group which is migrating should be anti to the leaving group present on this carbon. So students, we can see that the ring cannot contract in this case because this is not anti to the leaving group. So one is not going to give us a ring contraction compound. Let us look at the second option now. In the second option, we have both the NH2 and the OH groups present at the equatorial position. So if you look at the structure, it will be something like this. And again, upon reaction with NaNO2HCl, this NH2 shall be converted into N2 plus, and it will be converted into a good leaving group which is ready to leave. Now students, we can see that the ring can contract in this case as this is present in the anti position. Okay, so this will easily undergo ring contraction, and it will give us the following structure. And while the lone pairs of oxygen will attack on this carbocation and correspondingly convert into an aldehyde. Okay. So the compound Q is going to give us the compound A. So students, here we can generalize that whenever the leaving group is present at the equatorial position, this ring can migrate easily as it will be anti to this. So in cases where we have the leaving group present at the equatorial position, ring contraction will easily happen. So looking at structures R and S, we can see that structure R also has NH2 at the equatorial position. It will convert into a leaving group, and it will lead to ring contraction again. So R is also going to undergo ring contraction upon reaction with NaNO2HCl. And if we look at the compound S again has NH2 at the axial position, and we had already seen in the first case that when the leaving group is present at the axial position, the ring contraction cannot take place as the migrating group will not be anti-periplanar to the leaving group present over here. So compound S is also not going to undergo ring contraction. So only compound Q and R, in which the leaving group is present at the equatorial position, are going to show ring contraction. So students, we have to mark option 2 as the correct answer to our question. Let us look at question number 35. Identify a pair of functional isomers. So students, starting with the first option, the species given in the first option are not isomers as they have different formula. Okay. Looking at the second options are isomers, but both of them are ethers. They are metamers as the alkylation is different, but they are not functional isomers. If you look at the third option, we have a ketone and then an aldehyde, both of which have 4 carbon each. So these are functional isomers. Okay. And if you look at the fourth option again, the species given in the fourth option are not isomers as they have different DU. So DU are different, so they are not isomers. So we have to mark option 3 as the correct answer to our question.